And the screen sharing. Freigabe. That's the right window. This should be full screen again. Zack. Good. So today we'll just continue with our string X class. So let's see what the next nice thing would be that we could implement. So we have already written a list of to-dos. So what a string should be able to do, and which functions are the typical convenience functions that are required to nicely be able to work with strings. And here's our list. So I would suggest we just start at the top. So the append function seems quite easy. So the way it is to be implemented is you first need to check the length of the string that you are appending. Then you check, so because if it's 0 then you don't have anything to do. Then you check if our current capacity, which is defined in this variable, is actually long enough to contain the additional characters. And if it is, then it's great, because then we just can copy the new characters into the existing memory and increment the length variable. But if it is not, then what we need to do is we need to dereference the whole string object. Well, first we need to make a new one, bigger one, copy the one we have over, then dereference the one we had, assign the new one to ourselves, and then we can add the new characters. So the prepend function will be similar, just that the data are to be inserted at the beginning, which means that you always need to move the data which already are contained in the string around. So it's just a small complication. So who would like to start implementing the append function? Okay, great. Then let's do it. Yes. So it should have a void return type, and as argument take a const pointer to a CX string as reference. I would append the CX string objects directly. That's more flexible. Because we have a constructor that casts from a char, so in principle if we would call this append with a C string, normal C string, then it would automatically be converted. It would add some computation and memory allocation steps, but it would work. And for later we could of course add like a second append function that takes the other type, but I think the more generic approach is always the one that you should implement first, because then once you have this generic, you forgot the argument name in line 46. And the add character after string X so that it's a reference, not a full copy. It's the same definition like in line 34. Yeah. Now it's a reference, so like a pointer, just that it's a bit abstracted. Yeah, that's good. Yeah. We should not mix function and argument names. Anyhow, what I was saying before, it's generally more convenient to implement things first the generic way, because then already your code does everything you want, and then if you see that you are losing performance because you have a lot of appends of constant strings, then you can add a specialized function which will take this particular argument type and then perform the operation in a more efficient way. Another thing that one might think of with regard to our string class that we haven't thought about yet would be to make it somehow able to take strings just as reference, but this is a bit risky, so for now we will not be doing that. Mhm. Yes. No, 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 it has a name. It has a name. We called it M. You make M arrow, and other ulenk will not work. You need other arrow M arrow. Actually, no, you need other dot, because other is a reference, so it behaves like a local variable. Not well. Under the hood, it's a pointer, and if you compile with a pointer or with a reference, it makes the same code. But the way you refer to it in your C code, so it makes the same assembler code. But the way you refer to it in your C code, you have referred to it like a normal variable with the dot. So dot m arrow length, and there is a catch because length, of course. But there is a small catch because we are appending, so you need to take into account also the existing length of the current string. So basically you need the mulen plus other ulen must be still bigger than mu capacity. Yeah. Yes, you can. So you basically would use, for example, a function like memcopy, and as a target you would use m arrow p data plus m arrow ulen. You need to multiply time size of t because memcopy works in byte. Then as an argument, the second argument is then the other m p data, and the length is other m ulenk times size t. And that should work. One more thing to remember, copy one character more, because the way we have defined our string is that they're always null terminated. So we can always expect to in other to be one character more inside the array with the null. And since in our new or our modified string we also want the null, instead of manually writing the null assignment at the right offset, we just copy one more character, which is the most efficient way to do it. Uh-huh. Well, first of all, there is a mistake in line 61, which, if you run a test case, will become apparent instantly. Secondly, we need to, of course, update ulen to the new length. Basically, just add to it the u length of the other. Doesn't matter. You can use the plus equals operator. That's more convenient. Yeah, less typing, slightly less typing. Okay. Right, I said there is also a small mistake in line 62 which will become apparent. And the next thing is that in line 56, the way we have currently created our strings, we expect this to pretty much always happen. So what we need is, if this happens as expected, that we then create a larger data block for us so that we can we have room to copy to. So you can look into the constructors how this works. So as you see there, we create a new s string x asterisk with create, which takes in line 27, which takes in principle it takes as argument the capacity. So you then just would feed to this the new capacity that you expect to need. So basically the length of the two strings added to each other, and then you copy first the old string into this thing. You set of course the length, and then you call attach. And if we go to the definition of attach, you can there are easier ways to do so. You see that it even releases already the old data for us. So you only need to do the attach, and then everything will be taken care of. And from there on, you can continue. So basically, you don't need the existing copy that you have made now. You don't need the else case. You just drop the else case. You just keep the thing inside the body of your else to be always executed. And you only have above the if case, if it's not enough space, then make space. And then the copy will always work because the space has been made if it was necessary. You keep the body of the else, you just remove the else and the brackets. And of course the if will not have a break because we want to continue after we have reallocated a new memory. uh, well, you pretty much can copy the first four lines, so from 27 until 30, and then just modify them accordingly. And then the attach you will also need, but that was a line too far down. And of course this needs to happen inside the if, because we only want to reallocate if we don't have enough space. Yeah. Attach should be also inside the if because I mean this would not compile because p is in the wrong scope, so it would not be found by the attach later at all. Let's see. So well, ulen is undefined. You need to define ulen. And in the line 61, you will also need to change one of the arguments. Two of the arguments. It should not be other p data, but it should be p data. Because first is the target where you are copying to, and the source should be other p data, other mp data. Yeah, and the target is p arrow p data to be exact. Yeah. Okay. Length. Okay. In this code block there are still two mistakes. Can you spot them? Okay, one mistake is in line 61. You don't want to copy ulen, but you are copying from other. So what you want to copy is other m ulen, ulength. Not capacity. Yeah. And the other mistake is in line 57. First of all, you of course need to specify the argument, the variable type, and secondly, we want a different value as ulen. We are appending to an existing string, so that needs to be slightly modified. That it looks good. Length plus len, create, copy len. Okay, that looks promising. That should be working. At least I don't see anything wrong with it on the first glance, so that's already a good sign. Yeah. Right, and in line 67 there is a mistake, but if you cannot see it, just try your code out, and then it will become apparent what's wrong. String append string print. The yeah. It will be fine because it's different case, which often I find is case sensitivity might be sometimes annoying, but in this case it will help us a lot. Well, myString, it doesn't know what to do with myString. You need to use myString.cstring, like in line 33. Right. You need to specify a type for ulen. I think I already mentioned that. Yeah. Now it should be fine. Or not. Did I just double click on it? Yeah, other m must be, not just other. Oh, and I just noticed there is another mistake in the code, but we will test it first like this, and then we will take a look into the other issue. Yeah, you just take the sum. You don't need s x strlen because that would be just counting. You don't need to count anything. There are actually two errors. Other should not be just other, but other MP data. Yeah. There is still a second one, but the second one will become apparent in the test. Okay, almost. Yeah, this is always the case. You just can drop the... Just remove the if. Oh, and there is another mistake there. Well, just remove the if. And I just noticed there is another mistake in this line. You want to copy not from other, but from just m. Because you are copying the current object. Just remove the other here and there. Yeah. And you can remove the error message line because now it will not bug out. Okay. It should compile, I think. Yeah, that's some breakpoint. You can just remove the breakpoints and or press play. We'll run to the other one. Yeah, just remove both. Okay, and then we can already look into the new window that opened on the taskbar. Test append, and yeah, test case is missing. So where does MP data points to? Yes. And what is this data in this point when we run your test case? Yes. But memcopy doesn't know that it should append. Memcopy just copies whatever you give it at the memory address that you have given to it. Yes. Almost. You can either write in brackets mulen, but this gives you the null. Yeah, the offset is right, but it will not compile because this expression as written here will give you the value of the character, but you want its address. So you need to add an end sign before the m. No, before it. Yeah. Now it should compile and it should work. Let's see. Wait, now it didn't. What? Well, my string append what? That looks fine. That should work this way. You press the pin. Mulen plus ulen. I don't see on a first glance why that would not work, because that in principle should be fine. Put a breakpoint in line 65 and run the code again. Oh, I know why. I already know why. This line should be this line should be the next one. We are just appending into invalid memory. Okay, let's run it. We don't need the breakpoint. What? It still didn't work. And it okay, let me have the mouse. I'll take a look. Well, we have... Wait, that should be fine. We have attached the thingy. Do we do this? Okay, well, we do this. We attach the thing. How large is our new M? 12 doesn't look right. The attach failed somehow. So P length and capacity 12, and they have length of 8 and length of 10. Oh wait, that's 12 in hex. That should be fine probably. Yeah, 18. That looks like. Let's see. Yeah, that's fine. That's fine. Okay. So the length looks correct. 18 is fine. But then here it also will be fine, because it was just in hex before. We can take this memory and see what it will point us to. That is not quite right. There is a bug. This thing should be just the length that we had before. Here in principle we could do P, but doesn't matter. That doesn't matter. Let's leave it as is. So this was the error. We were kind of setting the new length to the length of both of the strings. Well, we wanted to keep the old length. Let's try again. I'm quite confident now it should work fine. Test case, test append. Very good. Right, so the other issue I have mentioned before is that if we would... We have here my string, my other, and we just assign to it my string, and then we will print here both of them. My other will also be modified, which is not good. What? Oh, because it always copies. Okay, so the thing is, what we want in this test here, we want to test for a second condition. Since accidentally we always run into this case, we don't trigger this bug. But if we would, but actually I want to trigger this bug. How do I do that? Len, comma. Okay, so if length is -1, then we need to measure the length. If capacity is -1, then capacity is equals length. As if capacity is less than the length. Okay, actually that's the same case. Okay, then we take capacity instead of len, but here is length. Length and length. Good. And now when we create a test append case, we say -1, 100. So we tell it that to pre-allocate more room so that we don't fall automatically into this case here. Now when we run it, as you see, my other also has been modified, which is not what we want. When we do an assignment, we want these objects to be effectively independent. And to make them effectively independent, we need to have here a second test case. If m refs is greater 1. So if more than one object refers to the same m, meaning that m is shared, then whichever object wants to modify m has to first make an own copy that it owns itself. Can we improve on that? uCapacity. So we call this uCapacity, not uLength. And we don't want to shrink our capacity, so we'll go with m. It will take capacity. So if we had already some extra capacity, do we want that? No, we don't want that. It was fine as is. Almost. Let me think. Okay, if capacity is less than capacity, then it's equals capacity. Now it's right. So the idea is that so if we follow the first case, your code is always fine because capacity was never enough. But if we fall into the second case, then the capacity that m had before might be greater than the capacity we need, in which case we don't want to shrink the capacity, so we always then take the bigger value, and then we just continue with the rest as it was. Nice. One more thing, I would here just make return and that's it. We don't need an error message, and less indentations make the code more readable. Nice. Very nice. I think this should work perfectly. There is a special case, but we don't need to handle it. So if we check whether this is greater 1 and someone while this is being executed, probably most likely while this is executed, in another thread, another string removes a reference back to 1 less, which will make this not longer greater 1. But this we don't really care because then refs is how many objects are referring to this one internal structure. So as soon as we make this operation, both my string and my other are referring to the same object, and we want this to be always 1, otherwise it's shared and we cannot modify it. And it might happen that while we are copying it, the other instance will go out of scope, which pretty much means that this operation was unnecessary, but it will not break anything, since attach will then just in the release, since this is done atomically, see that the thing is to be released and then free it. So basically we'll make a copy, release the other thing. It's a bit wasteful, but it's a rare condition. It only happens if you have a race condition, which shouldn't be too often anyways. So it's still safe, even though these operations here are not done within a lock that would guard refs. Good, very good. So let's see, the next function will be the prepend function, and maybe Mr. Akram would like to try it. Okay, then maybe Miss Chiara. Yes, it says someone disconnected. That's a good start. Correct. Mm-hmm. Correct. Mm-hmm. We are missing a starting bracket before emulen. The other one. Yeah. Yes. Mm-hmm. Yes. The line 85 was fine with the +1. Yes. Mm. Yeah. There is something in line 86 you need to change. It's MP data without the brackets and the end, because you want to copy the data to the beginning. Now, as is, you would overwrite a portion of the other data. The first argument should be only m ROP data, nothing else. Okay, good work. Now we need a test case. You can just comment out line 32 and make your own append line instead. Yeah, let's run it. What? Just click on the first arrow, then we see what's wrong. Huh? Oh, I broke something. Yes. May I fix it quickly, because this error will also be then contained here. Okay, and run again. Yeah. Test prepend test case. Yep, that worked. Okay, that was a very fast and short function. So maybe we follow on this trend and add one more. Void insert other comma insert o index. So if you would like to implement this function as well, so what it does is it's like prepend kind of, but it doesn't prepend at the beginning, it inserts somewhere in the middle. So you need to only shift a portion of the data and then insert at that position. So it's in principle a copy of prepend, just with a little bit more pointer arithmetics. Correct. We need to find the position, the index. Well, the index is provided. It's uindex. It's where we want to insert it. And we only need to move all the data that is located after uindex to the right. The data before uindex can stay where they are. In the right place, yes. U index in line 90 is defined. It's the position where we want to enter, to insert. So the closing bracket should be a square one. Small typo. Yes, but still +1. You need to add a add symbol before the m because we want the address, not the value. That might be working. We need a test case. Sorry, then make it non-capital in the header, so that we, I think at least, because the other ones were non-capital, so that we keep the same style consistently. And we need, of course, to specify a position. No, this was already okay as is. You don't need any more arguments in the constructor, but in the line 36 you need to add the index where it should be inserted. I would suggest index 4, that will be between test and case. Yes, a second argument. Yeah. Then the result should be test insert case, if it works. Let's run it. And let's check it. Test insert case. Perfect. Well, that was also very fast. So maybe another very quick function. May I have the mouse for a second? So following in the same gist, so we have insert, and the next obvious choice would be the remove function, which is even simpler in some ways at least. We just start with copy our insert, we just call it remove. But now we don't have the other thing, we only have index and length. So index tells us where to start removing, and length tells us how much to remove. And since the string always only shrinks, we don't need... Oh yes, we need it. We need it because we need the second case. Because we always, as said, when we modify something, we always want to take the exclusive ownership of the object. That should be already it. So we don't need to calculate the length, and we could even simplify it more by just by doing it like this. Yeah, we create a new thing, we set length, we copy, we attach, and then we can do with our current object whatever we want. So in principle, this will only need a modification to uLength and only one mem_move operation. Just again with the right offsets. So just to give an example, if we have test case and feed to it remove, let's say 2,4, then the result should be these. Yes. I think it might be easier to just write the line from scratch. You can keep the line for reference, just write a new one, because it's a bit more convoluted what's happening. But if you want to modify it, it's also fine. Let's see. Length will be not quite. You also need to remove the length that is to be removed, I think. Right? Right. It's just called uLength. And still +1, because you always want to move the 0. Okay. You still need to adapt the source, and the second line goes away completely. But in the first line, you still need to adapt the source and destination positions. No, just index. Because at index we start cutting, so at index something new, or rather the later portion of the string will start. Just remove the plus. Well, and the thing after the plus, of course. Okay, and the source will be index plus length. Okay. Line 26 can go. And line 27 needs a very small tweak. Okay, it's 2 tweaks. Well, we removed something, so it needs to get smaller. Just minus u length. Well, minus equals u length, and the rest can be removed. Yeah, and the rest can go. Right, that might work. In line 113 and 14, this can be removed because we don't have the other object. Although you could replace it with just if length is 0, then return, because this means we are not removing anything. That's a nice quick. Yeah. Yeah, but you don't need to specify any remove what. There is no remove what. We are removing. You just need 2 and 4 as arguments. You can leave that. That doesn't matter. Just write in line 47. Remove open bracket 2, 4 close bracket semicolon. Yeah, and let's run it. And see what it did. Yay! It worked. Great. Good, I guess that's enough. Let me have the mouse for a second. Yeah, you can disconnect. Let's see. So there are... Yes? Exactly. That's why the well, we are basically starting taking the data at, so we specify the index from where we start removing and how much we want to remove. So then we take the data starting at the last index that would be left untouched and move it, copy it to the left, is to the position where the first removed character is located. Good. Okay, so there are a few things which should be improved security-wise. So in the inset function, we might specify an inset offset which is simply not valid. Like if you want to insert past the end of the string. So if inset is larger than length. Wait, if it's equals, then it's also, let's see. If it's equals, then it's fine, because it means insert at the end. So if this is greater, then we just truncate the instruction and just say insert at the end. And the remove one also needs a safety check. First of all, if index, if index is greater or equals m length, then there is nothing to do because we want to remove somewhere where nothing exists. And then the length we are removing, that also might be a problem. So if index plus length is greater this thingy, then we just want to truncate length to be equals well, to be equals however much is left in the string. That will be m length minus index. Yeah, that should do it. With this, well, if it's greater or if it's equal, yeah, and if it's equal, then this will be 0. So if length is 0, then we can just return because there is nothing to do. If index is greater u length, then we just also nothing. That should be all the edge cases taken care of. Okay. I guess since the two people that wanted to do something already did something, we will keep the rest of the functions for the next time. So then we will, in the next lecture, continue with compare and then find, and then we'll see how far we go from there. But we can take a look what we could improve here. Yes, sure. In which line? In insert? Mm-hmm. Because we want only the length of the string which remains. And the length of the string which remains is so basically the string, our test string, is made out of those three things. TE is our index, is this thing here points after TE. This thing is this. Wait, this. And here, so we have the whole length would be 8 plus 1, but we want to remove so we basically just want these two characters, so we need to this length, so this is one thing that we remove, and index starts from 0, so it counts the length of this what we remove, so in total index plus length are those two, and we only want the last two because only they are shifted. Right, and we can make one more improvement in prepend. Just by replacing it with insert at 0. Oops. Insert at 0. And let's see, can we also make this with append? Would be nice if we could make append also work with insert. Would just need to make a special case. So if index is equals -1, then then index is equals u length. So we're just inserting at the end. That can be an else case. And if this is true, then we don't need to move anything. If index is equals ulength, then we don't, so it must be index must be less than ulength basically. Then we need to move, because otherwise we can just insert directly at the end, and then our prepend will become inset at -1. Yeah, that could possibly work correctly. Then let's try it out. So let's test if append works. Test case, test append, yeah. Append works, prepend. Test prepend test case, yeah. It works nicely. So we have optimized our code quite a bit. It's more maintainable if we have less code, and it should be closely to just as efficient as the other one. So the most inefficient parts is the memory allocation and copy. In some, especially in debug builds, also here the call to free, which might happen, might also be quite inefficient, because in some debug heaps the thing will try to validate if there was no corruption, so it will need to go through the memory and look at the right spaces for the right markers. But that's only in debug build. So this code is still in all the functions. So just a few more checks and ifs that usually doesn't really make any difference on the reasonably measurable execution speed. Of course, it will do like 1 or 2 instructions more, but the processors can do billions of instructions per second nowadays, so this will not usually be any problem. And it makes the code more maintainable. The remove is, I think, good as is. You can make it a bit more streamlined. This can be 0, but it looks nice like this. If this is greater, then we have nothing to do. Yo, that is okay. Cute. Then I think this is it. Oh, I see. Few more people arrived at the very end. So let's see, would we have anything really quick to do for them? 15 minutes maybe. So would one of the 2 days latecomers would like to implement a short compare function? Maybe Mr. Thala? Yeah. So we just finished the other functions, so that's absolutely not a problem. So what we want is a int compare other function, and the way it should work is that it will compare the other string with the current string, and if the other, and basically you make a loop and you compare characters at the same offset, and if you find 2 characters which are not the same, then you check if the current character in the current string is bigger than the character in the other string, you return 1, and if it's the opposite, you return -1. And if you manage to finish the loop without finding a different character, you just return 0, indicating the two strings being the same. So to do, and you need another to do at the beginning. You need to compare the lengths of the two strings, because if the lengths are not the same, then the strings cannot be the same. So just and you return 1 or -1 based on some defined semantics. So for example, you say if the current string is larger than the other string, then you return 1, and if the current string is shorter than the other string, then you return -1. You need to connect remotely with the VNC client. Okay. You only need the name other, you don't need to specify the type again. That does not look quite right. You need to check the length. So what you need to compare is other dot m error u length just dot not dot greater than m error You need the minus. Error is a two-character operator. uLength. Okay, and then if this is less than m error uLength, then you return 1. And then you compare if the other one is bigger than the first one, then you return -1. And if they're the same, none of the ifs is triggered, and then you can proceed to the loop. Well, we want to return. Okay, not quite done. So if you have a if that returns, you don't really need to write else if, because you will not uh, continue execution further down. And it looks better if you add another tab before the first return, but that's just optics. Just add a tab in front so that it has the same indentation as the other return -1. It's just for looks, it doesn't have any functional meaning. Move to the beginning of the line and press the tab on your keyboard. No, up, and now, yes. Good, now it looks nice. Right, yo, so now we need our loop. So we know already that the strings have the same length, so we can loop from, let's say, 0 to mu length, or to other mu length, it doesn't matter, they are the same. And then we compare the characters inside. Well, you can call your variable whatever you want, for example, I or index, it doesn't matter. Just remember to specify first the type before you write the name. No, the condition is if I is smaller than the length of either of the two strings. And since they are identical, you can just pick m length or other m length. It doesn't matter. Both are fine. You don't need to print anything, you just need to compare the characters and return 1 or -1 on a mismatch. No, now we don't compare the lengths. We already did that. We want to compare the values of the characters at the position I inside both strings. So for example, you just compare m p data square bracket I with other dot m arrow p data square bracket I, and if it's less than, then you return -1, and if it's greater than, then you return 1, and if it's neither of the above, then the loop continues to the next character. And if the loop terminates, then it means the strings are the same. Yes. So you want to compare, you write m arrow p data. Arrow is always two characters, minus greater. And now square brackets and I inside the square brackets. This gives you a character from MP data at the index of I. The square ones, not the curly ones. And you'd compare if this is less than other punct m and the rest is the same. No, the other way around. Ada.m. Well, and then mp data square brackets. So we still, of course, need to address the variable inside m correctly. No, not 0. Let's see, if m is less than, then return -1. And then you just need an else. Sorry, no else, because since we are returning, you can just write if and check the opposite case if the if it's greater than. Good. That looks functional, and since we are over time, we won't be testing it, but it's a simple, very simple code, so I think it's fine. One more question. I have in my list of students 2 people with the same name. Can you tell me your matriculation number? Yes. Mm-hmm. Okay. Good. Then I know which one you are. Good. Then that's that. Yeah. I'm referencing the list of people that registered. I guess only one of you came, but since now you did something, I need to record that correctly, and I need to know which one you are. Okay. Right. We are over time, so we should quit quickly. One more note to all of you: if we have since this is a bit more interactive in nature, it would be good if you don't come that late. You should come early enough so that you can participate. That's to all the 3 now latecomers that apparently came very, very late. Good. And then we will see each other in 3.5 hours for the lecture, or next week if you are not participating in the lecture. Which case, yes? Well, apparently you are homework free today. Mm-hmm. 155. Oh, yes. Okay, then let's see if it even compiles. Yeah, now it compiles. Then it probably will be fine. Good. I will upload the recording to YouTube as usual. Upload this to Moodle. And we'll see each other soon. Then, bye bye.